Now we're going to look at finding the inverse of a logarithmic equation. So remember, if we're starting with a log, we should end with something exponential. So we should not end with a log, or start with a log and end with a log. If that's the case, we did something wrong. Now remember, if you don't see a base, it's just a base 10. So when we're done, if we're starting with a log base 10, we should end with an equation with something that has an exponent with base 10. But first step, whenever you're finding the inverse, always switch your x and y. X equals log base 10 of 2y to the third. So, if there was something being multiplied by this log, like say it were 3 times log 10 of 2y cubed minus 8, we would have to get rid of that 3 and that 8 first. But because there's not, this first step is going to be to undo the log. Again, the opposite or the inverse operation of addition is subtraction. To move it to the other side, to undo it, you know that. The inverse operation of a log base 10, when you move it to the other side, is making it an exponent with base 10. So whatever you had over there stays, but it now becomes the exponent of 10, and now we have 10 to the x. So that's it. That is gone now on the right-hand side, and we have 2y cubed. Okay, we're going to divide by 2 to get rid of that there. So 10 to the power of x over 2, it's a fraction, which is okay, equals y cubed. And then we're going to take the cubed root. So cubed root of both sides. So we've got the cubed root of 10 to the power of x over 2 equals just y. Now we need to rationalize this. This is 2 to the first. We can't have a 2 sort of in that denominator. So we need to multiply both of our numerator and our denominator by the cubed root of 2 squared. We need 2 more to get to that 3 out of 3. So 2 squared is really just 4. So the top is become 4 times 10 to the power of x. So let's see here. We're not going to multiply 10 times 4. We're just going to keep it as 10 to the power of x times 4. But this will be over 2. And that's going to be our inverse. So don't forget to rationalize if you have a denominator underneath a radical. So number 7, switch your x and y. X equals log base 6 of y minus 2 plus 1. Alright, subtract your 1 over. Log base 6 of y minus 2. So the next step here is undoing that log, and we will make it an exponent base 6 on the left-hand side. So we've got 6 to the power of what? Whatever was over on that left-hand side. So 6 to the power of x minus 1 equals y minus 2. The last step will be to add the 2 over. So we have our equation for y. Again, we would be fine here. I'm just going to rewrite it in correct mathematical notation. So to write it in inverse notation, f to the negative first of x. All right, next one. Next, log number 9. So x equals, again, no base. So base, well, there is a base. You just can't see it. Log base 10 of x minus 2, and not x, y. Switch that x and y. So first step is going to be to add the 2 over. X plus 2 equals log base 10 of y. There's nothing being added or multiplied by that logarithmic expression anymore, so the next step is undoing it. So we now have 10 to the power of whatever's on that left-hand side, x plus 2 equals y. So we would technically be good to go here. Again, I will just write it in inverse notation. So 10 to the power of x plus 2 equals g to the negative first of x. Let's do one more. So number 10. F of x equals 3 times log base 2 of x minus 1. Switch your x and y. So here, 3 is being multiplied by this log, so we would need to get rid of that or take care of that first. So if it's 3 times that, we're going to divide both sides by 3. That will go away on the right. So we'll have x to the third, or x over 3 equals log base 2 of y minus 1. So now we're at the step where we need to undo the log expression. So we're going to bring this over, and we're going to have 2 to the power of x over 3, which is fine, equals y minus 1. And the last step is going to be to add that 1. So 2 to the power of x over 3, or x thirds, plus 1 equals y. Again, you are fine here. You can leave it as y equals. I'm just going to write it in inverse notation. So 2 to the power of x over 3 plus 1 equals f to the negative first of x. And if you guys want to write, if you like the f of x or the y being on the left-hand side, you can put it on the left-hand side. It's just that's always where it ends up, so I just leave it. But you can switch it if you like it on the left-hand side. That is fine. So if we start with the log, we should end as an exponential. So none of our equations have a log left in them if they started with a log in them. So that's just a good check for you guys when you're done with these.